this is the code together with the PC. Here, the PC 3200 and until 3204. So the PC is
So we
given.
cannot see your screen.
Can I see the screen?
Yeah.
What?
Sir, you are not presenting.
Yeah. Can you see my display?
Yes.
Okay.
Yes, sir.
Yes.
Yes, sir.
So this is what I mean by the first example. So therefore, example, you can skip the last one, and I advise you to go through the first, second, and the third example. But for this class, today I will help you to trace the code in binary language, which is represented by 0 and 1. And normally, the code will come together with the PC, which is address for the line. So this is normal. It will be given in the exam or anywhere you go. Normally, the code will be attached with the PC. When I say PC, so it means address. So when I say address, it means the address, the number that start with X. X means hexadecimal. So each programming code has its own address. So it is given. And at the left side, you can see the flow chart of the code, what is happening in the code. And normally the initial value, the starting value will be given. For example, in this case, the code, the function or the purpose of this code is to multiply the two unsigned integer, which is unsigned mean positive number, in R4 and R5. And normally for the register, the initial value will be given. For this example, the initial value for R4 is 10, while the initial value for R5 is 3. So this is the initial value that will be given in the equation. And then you need to trace the code that is given. So at the right side, you can see the flow chart. You can see the first box here. It's written there, clear R2. What can you comment about this register if the instruction is clear? What does it mean? What is the value of R2 after this process is executed?
0.
0. Okay, so R2 is 0. So now even though the initial value of R2 is not given, but from the instruction here, you can tell that R2 is 0. Okay. Okay, now the second step, add R4 to R2. So you can see the initial value for R4 is 10. So 10 add to R2. So what does it mean?
R2 equal to 10.
Sorry, pardon?
R2 equal to 10.
R2 equal to 10 because the value of R4 is added into R2. The content of R4 added into R2. So R2 is 0. So 10, you carry 10 and you put 10 in R2. So the value of R2 is 10. Okay, at this stage, the value of R2 is 10. How about the value of R4? At this stage?
Constant.
The same.
The same. The same, 10. Okay. Next, the next line, decrement R5. So what is the value of R5 at this stage?
3.
2. 2, Okay, R5 is 2. And then there is a apa nama ni? Before this we label this as a condition, condition. So the content for the diamond is a condition. So we need to test either the content of the register is equal with the value that have been set up. So at this stage, R5 is 2. So is 2 equal to 0?
No.
Of
No.
course, it's not similar. So the iteration process will be happen here. So next the next iteration add R4 to R2. So what is the latest value of R2?
20.
20.
20. So in the second round, the value of R2 is 20, while the value of R5 is
1.
1. So 1 is not equal to 0, so the third iteration will be executed. So add R4 to R2 was what is the latest value of R2?
30.
30. And then decrement R5. R5 will become
0.
0. 0. So 0 is equal to 0.
Yes.
Yes.
Yes. So the program will be stopped. Okay. So the content of R5 should be 30. 30, eh? The content of R5 should be 30, and the value of R2 is sorry the content of R2 is 30, while the value of R5 is 0, eh? So, but when you run this code, actually this slide already told you the default of the bug of the program, which is if you run this code, the content of R2 will be 40, not 30. So, what actually happened in this program? So this is the problem that we need to solve. Because when we do together just now, it clearly shows that the content of R2 in the end is 30. Yeah? 30. It's 3 o'clock. If we want to trace the program, we need to develop a table which is called as a tracing table. So this is the example of tracing table. Both table is can be considered as a tracing table. So by using this table, we can see the content of the register from starting at the starting part of the program towards the end. So how to develop this table? Okay, if you are given this type of question, okay, first of all, you need to find out what register that involved in this code. So what you can do is you need to compare this code with ISA table lah. ISA table. You need to open up the ISA table and you need to check what are the registers that involved in this code. So you need to do it one by one. So you need to do the first line here, 0101. So 0101 is refers to what or code?
N.
N.
N. Okay, the first and the second N.
Second and
Bit 5. 0, 1, 2, 3, 4, 5. Second N, because bit 5 is 1. This one is 1. So if you refer to ISA table, if the fifth bit is 1, so it means it is the second N. So in the second N, there are two registers, destination and source. So you can check here. The destination here is R2 and the source is R2. So it means there is one, at least R2 is used in this code. Okay. Next. Okay, 0001 is add. Add and then this is the first add or second add?
The first add.
The first one. So the first ones mean there are three register, which is one DR, which is R2, and then two SR. This one is still R2 and this one is R4. This one is R4. R4. So now we have two register, R2 and R4. Okay, next. This is also add. This is, I think this is second add, I think. Isn't it?
Yes.
The second one, right?
Yes.
Yes. Second.
Yeah.
So we made it 5. So we have here, we have R5 here and R5 here. Here we have R5. So now we have R2, R4, and R5. And then here we have branch. Branch doesn't use any register, and this is trap also. So at this from this code, we know that there are 3 registers that we're going to be used, which is R4, R5, and R4, R5, R2. So that's why here we have table with column for R2, R4, and R5. And don't forget the column for PC. This is compulsory because we need to trace line by line. Okay. So in the exam, you need to develop, you need to create your own table based on the available register. So just now I already teach you how to find out the register that used in the code, in the programming code, and then you create a table which consists of the column that represent the register. So in this case, we use R2, R4, and R5. And the initial value that is given is for R4 is 10 and for R5 is 3. For R2 is clear. Clear means empty, not zero. Clear means empty. Okay, so this is the starting point, 3,200, which is the content of R2 is empty, and then R4 is 10, while R3 is 7, R5 is 3. So now we start to trace the code. Okay, one thing that you must remember is if we want to check, let's say instruction at 3,200. Okay, let's say we want to check the instruction at 3,200. Okay, in the table, the effect of the execution of this line, okay, the effect of the execution of this line can be seen in 3,201. This thing you must remember. Okay, let's say we want to check what is happening to the register in 3,202, 3,202. So you can see the effect. If you look at the table, the effect will be appear at 3,203. Okay, that is the key that you need to remember before we do tracing. Okay, any question?
No, sir.
No, sir.
No, sir.
Okay,
No, sir.
right. So now, okay, we trace what is happening in 3,200. You see, it tells us that just now that this is the end of code, END, and this is the second end, isn't it?
Yes, sir.
Second end. So you can see here the immediate 5 means 5 bits. IMM5. IMM5 means 5 bits. So here the 5-bit value is 0. And we end R0 with, what's the label in ISA table? DR or SR? We end IMM5 with source 1 or source 2?
Yes.
The first one, the second one?
So why
Source one.
Okay, source 1. So source 1 is R2. So end 0 with R2. Anything that we end with 0 will become 0. Will become 0. So the value of R0 will be kept in R2 here, destination. So the impact or the effect of 3,200 you can see in 3,201. Okay, you can see 3,201 here. The value of R2 is 0 because R2 has been end with 0. Okay, the value of R4 is still remain because at that line there is no there is no execution that involve R4 and R5. Okay, next 3200 3201. So what is happening here? So we know that this is add. We checked it earlier, and then we know that this is the first add because the fifth bit, 0, 1, 2, 3, 4, 5. This one, 0, 1, 2, 3, 4. Okay, the fifth bit is 0, so 0 means the first add will be used. So if we use the first add, so it means there are two sources. So here we can see the first source is here, which is R2, and the second one is R4. R4, and then we will keep the result in R2. So add R2 to R4, sorry, add R4, add R4 to R2 and keep it in R2. Okay. So the effect of this execution can be seen in 3202. Okay. So add R4 to R2. R4 we know the value of R2 is 0, while R4 is 10. So add 10 to R2 and then keep it in R2. So you can see at 3202 the value of R2 will become 10. Okay. So this is how we trace the code. Okay, the value of R4 and R5 are still remain. Okay, next, look at the next 3202. This one. Okay, here, what is the opcode that will be executed here?
The second add.
The second add. So the second add, we use immediate value IMF5 as well as R here.
When?
What? Here.
R5.
R5. R5. So add R5 with the value of immediate 5. So this one is immediate 5. So what is the value of this immediate 5? Only 5. 1, 2, 3, 4, 5. So what is the value of this immediate 5?
$31.
Pardon?
31.
30.
31? 31?
Yes.
31? I'm sure it is 31.
Oh, sorry. This one is negative. So it should be negative 1.
Negative 1. Negative 1. So it is negative, not positive. So R5, what's the content of R5?
Negative 1.
R5 is 3. 3 add with negative 1 and keep it in R5. So what is the value of R5?
2.
2. So at 3203, the value of R5 is 2. We can see here 3203, the value of 5 will become 2. Okay, the value of R4 and R2 are still remain. So next, 3203. 3203 here. So what is happening here?
Branch.
Is this an opcode for
This is branch.
branch? So branch. Look at the condition here. What it tells you.
Positive and 0 branch.
Okay. Okay. If the previous answer, the last instruction that we have checked, if the answer is negative or positive, the branch is taken or not?
Should be positive and 0.
I know, yeah, if the answer is negative or sorry, if the answer is 0 or positive, the branch will be taken or not?
0.
No, I'm not focusing on the answer just now. I just want to ask you the general question. If the answer is negative or 0, the branch will be taken or not?
If 0, no.
Yes.
If 0, no.
If 0, it will go.
We have learned this last week. What is happening if the condition is true? This one.
If branch true, the next answer is not in sequence anymore.
Wait, if branch is true. Wait, okay, this one. If the branch is true, means that if the answer is negative or positive, so what's next?
The next answer is not in sequence anymore.
Okay, next one. So what's the next instruction that will be done after 3203? Where we should go?
3201.
How do you get 3201?
From the last 6 bit.
The last 6 bits. So what's the value of the last 6 bits?
Last 6 bit is -3.
Wait, 000 is where? Branch. Okay, PC offset 9. So we have 9 bit, 333. Okay, the value is negative.
-3.
-3. So what's the next branch? I mean the next address that will be executed after 3002. What's the formula?
The formula is after -3, then +1.
+1 to where?
+1 to program counter.
Yeah. So what's the formula? PC plus
PC +1.
PC plus
PC
1.
kamu dah lupa kan? Mana dia PC plus offset plus 1 tu mana? Dia lepas dah ajar kan PC plus offset plus 1. Dia banyak kali cakap PC plus offset plus 1. Masih tak dapat jawab lagi. So apa nilai, what's the latest address of PC plus offset plus 1?
3201.
How do you get that?
-3, so 3200, and then +1,
From the
3200.
beginning, what's the value of PC? Jangan terus minus. So what's the value of PC?
3203.
And then
plus PC plus offset 9 is 3200, and then +1, 3201.
so that's why in the table there, after 3203, the address will be again repetitive to 3201. This is because PC plus offset plus 1. It is not 3204, 3204 over here. So that is the impact of the content of the table. So after 3203, the next RPC is 3201. Why? Because of this one just now. You already calculate the address, the new address. PC plus offset plus 1. So now at 3000, at 3202, just now the impact can be seen in 3203. So look at 3203 here. Oh, but we're not reaching this yet. We are here. So 3200, 3203. At this stage, the value of the value of R1, R5, and R4 is, you can check. R5 is already minus 1. Okay. R4 is still 10. Okay. And R2 is still 10. This is the first iteration. So you can see here at 3203, the value of R5 is already decreased 1. Okay. So at 3203, okay, we know that this at this stage the new address will be calculated, and the new address that will be the next instruction is at 3201. 3201. So in the table, we can write here at 3203, the value of R2 and R4 is still 4, while the value of R5 is already 2. Okay, now 32, and then we execute 3202. Again, we do the additional process, and this is the first add. So the value of R2, R4 will be added to R2 and keep it in R2. Okay, so we know the value of R4 is 10. 10. So 10, add to 10 and keep into R2. So that's why at 3201 just now, the value of R2 is already 20. But R4 is still remain, and the value of R5 is still 2. Okay, at 3202, okay, here we can see the value of R5 will be decreased. That is why in the table at 3203 here, the value of R5 is already decreased 1. And the value of R4 and R2 is still remain. Okay. Now we know at 3203, the answer is still positive. So this branch will be taken. Remember my word. If the answer is positive or negative, the branch will be taken. This is the answer that I want. That's the answer I tell you at the early of this class. I ask you what is happening if the result is true. So the answer is the branch will be taken. So now the branch will be taken because the answer is 1 just now. 1 or 2? Second round, 2. So at 3203, the branch will be taken, and the value of R5 is already decreased to 1 here. Okay, next. We go up again. Okay, as here. Okay, we know the value of R4 will be added to R2. So the value of R2 will be increased to 30 here. 20. Mana tadi? Kita stop dekat mana? R5 tadi berapa?
Still 2.
Still 2. Wait. I'm confused now. Here at so 3202. 3202, the value of R2 should be Here, 10 plus 10 is 20. And the value of R5 is 2. Okay. Next, at 3202, what is happening here? Again, the value of R5 will be decreased 1. So the effect can be seen at 3203. So you can see at 3203 here, the value of 5, Allah, the value of R5 will be 1. So next at 3203, again, the branch will be taken. Okay, will be taken, and at 3201, here, R4 will be added to R2. So the latest value of R2 is 30. 30. And then again, 3202. 3202, the value of R5 will be decreased 1. So 1 minus 1 is 0. Yeah. Yeah, 0. So if the value is 0, the branch will be taken or not? Should be taken or not?
Yes.
Yes, because the condition there is negative or if 0 or positive. So again, it will return to 3201. So at 3201, the additional process will be happen. So R4 will be added to R2. So we can see the value here, 30 plus 10 is 40. And then again, the value of 5 will be decreased 1. So 0, mana tadi kat sini Kamu tadi sini ke sini? 0, kita dah ulang. Dari 0 negatif, okay. Dari dah 0 kita ulang, so dekat sini lah. So 0 will be negative 1. So if the previous value is negative 1, so it is not fulfill the condition, so the code execution will be stopped. So that's why you can see here, the execution only stop when the value of R5 is negative 1. Negative 1, Negative 1. So if the value is negative 1, so how many iteration that this program executed? How many iteration?
Hey.
No, if we stop at the value of negative 1 for register 5, so how many iteration that we do actually? How many?
4 times.
4 times. 3, 2, 1, 0. See? 3, 3, 2, 1, 0. So 4 times. But here is clearly shows that R5 is only 3, not 4. So what is the problem actually here? It should stop at here when the value of R5 is 0. So if it stop here, we can get the cycle is only 3. So how to repair this code? Where's the problem?
Change the condition and branch.
The condition and branch. What should be the condition?
Only 0.
Only 0. Means that 0, 1, 0. Like that.
Yes.
Okay, if you say if 0, if I mean 0, 1, 0, means that only this one. Okay, how about if the previous answer is positive? If this answer at 3002 is positive, this branch will be taken or not?
Yes.
How? Because the positive is 0. I mean the condition for positive is 0. The branch only will be taken if the answer is 0 only. So how to set the condition? To make sure it stop at 3 iteration.
At 0, 0, 1.
0, 0, 1. Okay, look at the logic. If we put there 0, 0, 1, so means if the value of R5 is positive, okay, the branch is still taken. But if the value of the branch, I mean the condition is 0, here, 0, what's the next instruction to be executed? The 3000 3201 or 3204?
3204.
3204. So it will stop here. Okay. So this one is wrong. Apa nama, the condition is not Z but P actually. P not Z. Not Z and negative. See, that is how the counter works. So you need to develop this kind of table or tracing table in order to check the content of the register. You need to do this slowly, one by one. The keyword that you need to remember, as I told you earlier, if you want to see or if you want to tell us the effect of the effect of 3201 in the table, you need to see it in 3202. 3202. So if you want to see the impact of the code at 3002, so you need to refer to 3203 in table. So everything that happened in 3202 can be seen clearly in 3003. So education about the tracing method, tracing table, and how to repair error. Education.
No questions, sir.
Yang lain macam mana? Okay, sekarang ni kan korang keluarkan kertas, take out a piece of paper. Korang tak boleh tengok, you cannot only see, you just watch the table. It can't be like that. You need to do it. So take out a piece of paper. Buka, ambil kertas sekarang.
Dah. Terima kasih.
Okay, awal-awal tadi apa kita buat? In the beginning, what we are doing just now.
Compare code dengan ISA table.
Okay, compare code dengan ISA table bertujuan untuk kita compare tadi untuk kenal pasti apa? Untuk cari apa?
Dia.
Or code.
Mana ada check ISA table untuk cari error? Mula-mula tadi kita compare dengan ISA table untuk cari apa sebenarnya?
Oh, code.
Code and then lagi korang bayangkan korang dapat soalan ni macam ni, bodoh-bodoh macam ni je. Let's say you get this kind of question. So what is your first thing that you want to do? Tadi ambil IS table and then compare code. Lepas tu
And then calculate the instruction, the address.
no. I ask you to compare with IS table in order to find out what? Look at your paper now. What do you have on your paper? Guys, kalau if I ask you to do something on that paper, what is the first thing that you want to put on the paper?
Draw the table.
Draw the table lah. We are talking about table now. Itu bezanya. That's the difference if you just watch. I give a lecture and you just watch and look at just watch and listen. It's different with somebody who write it on a piece of paper. If you write in a piece of paper, you know that the first thing that you need to do is to find out the register involved. Why we need to find out the register involved? Because we want to develop a table. If we don't have table, how can we do the tracing method? Kosong je kertas tu, tiba-tiba nak jawab apa? See? That's why most of the students blur. They're getting blur when answer the question because they don't find the starting point, where to start. Kan? Padahal tadi saya dah beritahu dah where to start the code. Saya dah beritahu. Buat table dulu, pasti make sure apa register yang ada supaya kita boleh develop table tu. The table, the length of the table, we can't decide because it will be expand as long as the code is not stopped. We just only can set the column, how many column of the table by checking the register that involved. How to check how to check the register involved? You need to compare it with ISA table. That is what I told you just now. Next, after you compare with the ISA table, so what is your task? Of course, you need to develop an ISA table, the tracing table first. So what's next?
Interpret the first line.
Interpret the first line.
Address.
Kenapa ramai yang diam? Korang tahu tak apa yang korang buat? So korang ikut babi buta. Cuba korang buat. Can you imagine what is happening is this table is empty? Let's say you have no table here. What is your task to answer the question? Macam tu je. Nak jawab macam mana? Kosong je. So nak start dekat mana? Tadi dia cakap compare the ISA table with the code, the given code. Okay, good. Compare and then what's next? Jadual pun tak ada lagi, macam nak trace. Cuba buat jadual tu sekarang. Jangan tunggu buat jadual tu. Draw the table now. How do you draw the table? Muhammad Firdaus, tunjuk table kamu sekarang. Saya nak tengok. Show me your table. On camera. Muhammad Firdaus. Muhammad Firdaus, mana kamu? Yang mana tak jawab, saya kick dia dari tu kan. Mana gambar kamu? Kalau saya panggil tak menyaut. Mana pergi? Saya kata tunjukkan table sekarang.
Dia punya kolom ada PC, R2,
Tunjuk,
R2,
buka kamera, tunjuk. Tu tengah-tengah tu kolom untuk apa tu? Between R4 and R5. Muhammad Firdaus.
Saya doktor.
Tu kolom antara R4 dengan R5 tu kolom apa?
Tak ada, dia ada 4 kolom je. PC, R2, R4 dengan R5.
How to fill in the table? Buat satu-satu. Start daripada 3,200. Nanti saya ubah sikit. So I will change the content of the question. I want you guys to develop a tracing table for this code. I will change the code here. Empat, 8, 12, 17. 101, 101, 101, 1, 0. This one. This one is. Workshop 001 positif. If positive, if zero, but this is 01. Dua, tiga. Dari 10, 1, 3, 3. Dua, 1, 0. 1. Okay. Okay. Okay, now I give you this code. So you trace this code and determine either this code has error or not. Okay, buat sekarang. You do it now. After this, I want you to switch on your camera and show me your answer.
Sir, can I do the table in Microsoft Word?
Yes.
Okay.
Okay, trace the code and then show me the content or the value of the register that involved. And if there is an error, so please state what is that error all about. So that is your task now. I give you until 4 o'clock. Then after 4, you show me your table. I will call upon you one by one to do it now. Sorry, I show you the, I'm not showing you the code. So this is the code. I already changed the code and I already changed the initial value of R4 and R5. Okay, I changed the initial value of R4 and R5 and I've also changed the code here. Some of the code is already changed. And then I already changed some of the things in the flowchart. So your task is to trace the code and find out the error if available. If there is no error, so just proceed with your execution and find out the content of the register. If there is an error, you just get stopped and tell me what is the error. So anything is possible. It's possible. So do it now. We will start at 4 o'clock. Okay, 4 minutes left.
It's 4 o'clock.
Okey, sudah pukul 4. Muhammad Firdaus, tunjukkan jadual awak. So what is the first instruction output? Cuba cerita sikit, jangan diam je, bisu ke apa?
So yang jadual tu dia ada R2, R4 dan R5. So PC dia
Mana jadual mesti tunjuk.
tak boleh nak dua-dua sekali, doktor nanti dia akan live.
Okay.
So dia ada 4 kolom, PC R2, R4 dengan R5. So dia punya PC tu macam yang doktor bagi tadi, 3200, 3201, 3202 and 3203. So first one, R2 dia clear. So R4 will be 5 and R5 will be 0 for 3200 punya. Then continue with 3201. So R2 dia akan jadi 2. Then R4 will be 7.
Sekejap, okay, dekat 3200 apa awak punya output?
R2 clear.
Okay.
R4 will be 5 and R5 will be 0.
Okay, that one is 3200. Okay, and then 3201.
Okay, sekarang 3201 R2 dia jadi 2. Disebabkan dekat kita punya yang doktor bagi tadi tu dia punya R2 dia punya R5 tu equal to 2. So dia akan add kepada R4 jadinya 7. Sebab R4 dia 5, so 2 tambah 5 jadi 7.
Sekejap. Sekejap. Three at 5. One. This is 4. And then 3, 2, 4, and 0. 3, 2, 0. Okey, teruskan. Ulang balik tadi Muhammad Firdaus.
Okey, ulang balik. Okey, yang 3200 tu R2 dia clear. So
Okay.
R2
Okay.
R4 will be 5. Then
R4 will be 5. Okay.
Then R5 will be 0. Then I continue dengan 3201. R2 dia will be 2. Disebabkan dekat kita punya R5 tu dia equal to 2.
Sekarang awak refer dekat yang okey, sekejap cuba ulang first statement awak tadi. First statement ulang balik. Yang clear tadi tu. Awak sebut
R2 clear tu.
Wait, awak sebut sekarang ni saya nak tengok awak faham atau tidak. Okay, dekat 3200 tadi, okay, R2 clear.
Betul.
5, R4 berapa?
R4 will be 5.
With 5, R5?
R5 0 doktor.
Okay, and then 3201.
R2 dia 2.
Kenapa R2 dia 2? Kenapa R2 dia 2?
Sebabkan diagram ni doktor. Sekejap.
Diagram mana? The flow chart. Which diagram? The flow chart you mean?
Betul. Saya tengok R5 dia 2. So dia tak dapat, saya kira yang tu 2. Oh, dia akan jadi 0 balik doktor. Dia akan jadi 2.
Okay, dekat saya nak validation dekat 3201. What is the content of R2?
Dia jadi 0.
Dia jadi 0. Tadi awak kata the content of R2 berapa?
2.
So sekarang 2 atau 0?
Kalau ikutkan kefahaman saya, dia jadi 0 balik. Tadi saya salah buat. Saya ikut R5 yang 2, ikut flowchart tu.
Flowchart tak ada masalah. Dalam flowchart mana ada beritahu 2, mana ada apa-apa, tak ada apa-apa perbezaan pun.
Sebab saya kira ikut flowchart tu, R5 tu jadi dia akan jadi 2. So dia kena continue balik naik atas kan. Saya calculate macam tu.
Tak, kita tak sampai bawah lagi. Yang R52 tu itu dekat 3202. Sekarang ni awak cakap 3201 kandungan R2 ni 2. How can you get 2 for R2? Saya cuma nak tahu reason dia. How can you get 2 for R2 during 3201? And then suddenly you change it to 0. How come?
Sebab kalau kejap saya buat balik betul. Sekali lagi 3201 R2 dia akan jadi 7, betul?
7 pun nak sebut tadi. Macam mana boleh dapat 7?
7 tu disebabkan yang saya kira pakai flowchart doktor. So the first one 30200 tu kan dia akan jadi clear 5 dengan 0 kan, R4 dengan R5. So
Okay.
So 3201 tu R2 dia akan jadi
7.
not 7, 5 doktor.
Sekarang jawapan awak ada 4. Tadi awak cakap 0 and then 2 and then 7 and then 5. Which one is correct?
Okay, the correct one will be 5 doktor. Then R4 dia 10.
R4 10. And then R5?
R5 0 lagi.
Okay, next.
Next 3202 dia akan jadi R2 dia akan jadi 10. R4 dia akan bertambah. Dia akan bertambah menjadi 15. And R5 dia akan jadi 2.
Kat mana R4 dia bertambah ni? Tak, setahu saya yang tambah ni R4 tambah R2 simpan dekat R2. R2 yang patut bertambah. Awak dah mengarut ni, dah jauh sangat pergi ni. Fatin Nabila.
Yes, sir.
Show me your table.
So, saya masuk guna phone boleh, sir?
Berarti awak lah.
Sekejap
Kalau okay, Fatih Nabila, I can see you. Proceed. So tell me what is happening there. Don't just show the picture. Explain.
R2 ni sebab tadi kod dia sama kan. Dekat X3201 ni dia result daripada X3200. X3200 kita dapat komen dia R2 sama dengan kosong. So kat X3201 ni dapat kosong, R4 stay, R5 stay sebab tak ada R5 pun dekat dalam X3200 tu. Lepas tu dekat X3202 dekat X3201 tu kita dapat R5, R2 R2 sama dengan R2 plus R4. So R2 plus R4, 0 plus 5 dapat 5. So R4 still sama, R5 still kosong. Lepas tu X3202 dapat PC plus offset plus 1 tu tapi dia punya kejap, X3202 R5 ada R5 dekat X3202.
Ada R5. R5 memang ada dari tadi.
Dalam X3202 tu R5 sama dengan R5 plus 1. R5 plus 1. Kosong satu. X3202 macam ni. Saya tahu dia jadi X3204 sebab dia jadi dia dah tak true. Dia true. NZP.
Terima kasih. Okay, next Nur Eliza. Nak tengok jawapan seorang-seorang.
NZP.
Saya take note apa yang you all buat ni, saya take note. Nur Eliza?
Saya present Ustaz dalam Word.
Present lah macam mana sekalipun. Okay.
Boleh nampak ke?
Nampak.
Okey. Okey, untuk mula untuk X200 R2 dia akan empty, R4 dia akan 5 dan R4 dia akan 5, R5 dia akan jadi 0. Lepas tu untuk untuk 3201 ni R2 dia akan jadi 0, R4 dia 5 dan R5 dia 0. Kemudian untuk instruction untuk XP201 tu kita add R4 to R2. Jadi R2 dia akan jadi 5. R5 dia akan 0. Kemudian untuk instruction X3202 kita akan tambah 1 to R4. Jadi R5 dia akan jadi 1. Kemudian untuk instruction T200 dia akan jadi R2 5, R4 5, R5 akan jadi 1. Kemudian untuk instruction 3201 kita add R4 to R2. So kita add R4 5, kita add 5 plus 5 akan R2 dia akan jadi 10. Kemudian R5 dia akan kekal 1. Kemudian terusnya untuk instruction X3202 kita tambah 1 to R5. Jadi R5 dia akan jadi 2. Jadi untuk condition dalam flowchart tu, adakah R5 sama dengan 2? So kita akan stop looping untuk flowchart tu.
Okay. Hello, Eliza. Eliza? Eliza, are you okay? Eliza, are you okay?
Ya saya sir.
Dah
Boleh dengar?
Dengar. Sudah Okay. Next, Fatin Nabila sudah beritahu Eliza. Okay, Pramila. What have you got, Pramila?
So can I present the screen?
Of course.
So this R2 will be empty here, and then R4 is 5, then R5 is 0, then your R2 will be 0 also, then R5 will remain 5, R4 will remain 5, then R5 also 0, then here we need to add R2 with R4 will get 5, then R4 here will be 5 also, and R5 will get 0, and here for 3203 we will get R2 5, and we need to add 1 with R4, so we will get 1 here, and for here R2 5, R4 will get will remain 5, and here R5 will get 1.
Okay, thank you very much. Anis, Natasha?
Kejap sir. First, dekat 3200, R2 dia clear, R4 5, R5 0, 3201, R2 dia 4, R4 5, R5 dia still 0. 3202, R2 9 sebab saya tambah 5 dengan 4. Lepas tu R4
Sebab apa?
still.
Hilang.
Apa
Hello?
yang hilang?
Suara kamu hilang.
Dengar tak, sir?
Baru dengar. Bagaimana kamu dapat 4 tu? Kamu tambah
4 ni. DR untuk first instruction.
First instruction alamat Okey, tak apalah. Okey, tak apa.
Sorry sebab saya kurang faham bab ni. Tapi saya cuba je.
Okey. Siapa lagi? Fatih Nabila. Maizatul Syuhaida. Maizatul.
Saya pergi sana. Nampak tak, sir?
Nampak.
Okay, first untuk R2 X3200 3. Untuk R4 kita dapat 5, R5 0, 3201, R2 equal to 0, R4 5, R5 equals to 0. Dekat R3202, R2 sama dengan 5, R4 remain, R5 equals to 0. At 3203, R2 remain 5, R4 remains, R5 plus 1.
Plus 1. Kenapa awak pergi balik ke 3201
Sebab saya confused sebab sini branch kan. Tapi Z je Z dia ada Z. Tu yang saya confused. Kat sini Z kan, saya kan saya confused kat sini. Dia tadi lagi tersekat.
Biar kamu tersekat kat situ. Saya ulas.
Ya.
Okay, ni Asni Nadirah.
Yes, sir.
Tunjukkan apa yang awak dapat petang. Tak apa, yang mana salah nanti saya tegur.
Saya tak siapkan sebenarnya tapi sekejap nampak. Wait, sir.
Ni Asni ni yang plan nak drop tu kan, tapi tak dapat result lagi kan?
Sebab entah APK dia tak selesai-selesaikan saya punya permohonan.
Okey. Tunjuk jawapan kamu dulu.
Wait, sir. Ni yang saya buat, sir.
Okey, saya tak nampak. Okey. Okey, 550, okey. Okey, awak isi yang tengah tu je.
Saya tengah je.
Tu awak buat sampai mana tu? Sampai
Yang ni sebab saya tengok table dalam ni yang first saya buat.
Tak nampak. Tepikan sikit. Ke bawah. Bawah. Bukan itu, kanan. Tu ke bawah. Okey. Sekejap. Bawah lagi. Itu atas, bawah. Okey. Sekejap. Okey, sekejap. Close up lagi dengan kamera. Okey, sekejap. Wait. Tak nampak. Okey dah.
Thank you, sir.
Okay, next Nur Eliza sudah. Nur Atikah Syairah.
Ya, saya kejap Esa.
Ah.
Sekejap. Mana? Ini yang saya buat.
Okay.
Dapat tak?
Cuba ke kanan sikit. Okey. Okey, jap. Okey. Lagi. Ke kiri sikit.
Kiri.
Kiri. So tak clear. Dia boleh fokus ikut. Awak punya buku surat tu dia melengkung. Bila melengkung dia fokus pada yang melengkung tu je.
Sekejap. Tengok lagi dia tak melengkung.
Pelan sikit.
Okey.
Dia dapat lagi. Dapat lagi ke kamera.
Just.
Okey.
Tu.
Okey, jap. Awak kat mana ni? Kelantan ke?
Taklah. Perak.
Line teruk kat sana Sekejap. Saya tak nampak sangat bila.
Macam mana
Yang baris yang R5 saya dah nampak semua. R2 dengan R4 saya tak nampak lagi.
Okey, saya tengok yang ni.
Tunjuk satu.
Tak. Mana ni?
Okey, so jap. Okey, stop. Okey, right.
Okey.
Okey, jap. Kosong. Okey, saya dah nampak semua. Okey, saya dah salin di depan awak.
Okey.
Jap. Satu, dua. Okey, alright. Okey.
Terima kasih, Sir.
Sama. Awak perak kat mana?
Kampus Jawi tu Intan.
Tu Intan. Okey, Primela okey, Zangkaizing siapa lagi? Okey, ni semua international student je. Okay, I want to see Ho Kuan.
Okay, sir. So for 3200, this one is, the instruction is clear. So R2 is cleared, R4 is 5, initialized as 5, and R5 is initialized as 0. And then for instruction 3201, the R2 is, the instruction is add R4 to R2. So R4 add to R2, which 050 shows up at the next address is R2 becomes 5. So now address 3202, the instruction is increment 1 to R5. So 550 increment 1 to R5. At the next address, R5 become 1. So 551. 3203's instruction is branch if 0, but because R5 is positive, so no branch. And then it will continue to 3204. And then final result is R2 equals 5.
Okay, thank you very much.
Okay, thank you, sir.
Welcome. Okay, Ali.
Okay, sir.
Show me your result.
Okay. Okay, can see?
Yes.
Okay. For the first, we make sure R2, R4, and R5. We already get the value of the R4 and R5, and R4 is 5. The R4 is 0, and R2 is so first, beside the flowchart, we clear R2 and X 3201, and R2 is 0, and R4 is 5, and R5 is 0, and we add R4 to R2. So X3202. So we got R2 is 5, and R4 is 5, and R5 is 0. And next, X3203. So we beside the address, and R2 is 5, R4 is 5, and R2. We increment R5, so R5 is 1, and make a loop like before. For
until there. So I see for the branch I got some problem, so I can continue.
Yeah. So thank you very much, Ali.
Thank you, sir.
And then we have Dun Jianli.
Hello, doctor.
Ah,
Uh,
show me your table.
with me on my book.
Ah,
With me.
wait, yeah, we're waiting for you.
Teacher, can you
We
see?
can, yeah, we can see you. Close up, closer. Okay, closer. Only the table part, the top part. Okay, wait. 0, 1, 2, 3. Okay, 0, 1, 2, 3. Okay. Okay, thank you.
Oh, thank you, teacher.
Wait, I will comment later. Okay, that's it. Thank you. 3, 14, 11, here. Okay, the last one, Zhang Kaizing.
Hello, doctor.
Hello.
Can you hear it?
It's upside down. Okay.
Uh,
Turn your paper or camera. Turn your paper or camera.
wait a moment. It's okay?
It's not okay. Turn 90 degree.
Yeah. R2 is
Turn to 90
0.
degree. Zhang Kaizing, turn your paper 90 degree.
Ah?
Turn your paper.
反一下，反一下，
让你竖过来。
竖过来，竖过来。
Yes.
Yeah.
Okay, closer. Close to the camera.
Okay, the results R2 is 5.
Closer to camera, especially R5. I can't see R5.
靠近那个 R5。
Okay. Okay, thank you. No need to talk anything. No need to say anything. Okay, thank you. Thank you, Kaizing.
Okay, thank you, doctor.
Apa nama? Hokon. Hokon. Can you show me your paper just now?
Okay, sir.
Okay. From all, just show the paper. Okay. What can I conclude from your understanding by doing the exercise? 1, 2, 3, 4. 4 of you exactly give the perfect answer. Okay, Pramila, Atika, Zhang Kaizing. Okay, this is the answer that I want and we need. Like Nur Eliza, you do lots of iteration. Actually, the condition makes you make the execution of the program only once because it has been set as negative. Sorry, exact 0. So the iteration only will be executed if the answer is 0. But now the increment happened before the branch take place. So the increment of the R5 value, okay, avoid the iteration to be executed. So it will be stopped at 3000. It just happened once. The cycle, and then it will be stopped at 3204 right after 3203. So there are two of you that are totally wrong. So please screenshot this, siapa nama, Ehokon punya jawapan ni. Please screenshot this, and this is the correct answer lah. Okay, where at the first stage the R2 will be cleared, so it will be clear, nothing inside, and the value of R4 and R5 initialized by 5 and 0. And then during the first part, I mean the first line where the value of R4 will be added to, I mean wait, if you see the instruction just now, at 3200 R2 will be 0. Will be zero because the content of R2 will be end with 0. So that is why at 3201 the R2 is 0. Wait, I need sekejap can I show my slide first? I need your friend screenshot my display first.
Okay, so
Guys, please screenshot this code first. It's easy for me to explain to you. Just screenshot this with your handphone or anything that you can use to take a shot. Okay, done. Okay, dah done.
Done, sir.
So can show your answer back.
okay, so
So you can see here at 3200 there. So it is starting point. So R2 will be cleared. R4 and R5 will be initialized with 5 and 0. Okay. While if you see the code that I have changed, okay, at 3200, the output N will be executed where R2 will be N with 0. R2 will be N with 0 and will be keep in R2. So that is why, as I told you, the impact only can be seen at 3201. So that is why R2 at 3201 is 0, while R4 is 5 and R5 is 0. Okay, and again, you look back on the code that I gave you. Okay, look at 3201. At 3201, the AND operation will be executed where the value of the add. The value of R4 will be add with R2 and keep it in R2. And look at the table back. Okay, the impact will be, you can see at 3202. Okay, here the value of R4 will be added with R2. So we know the value of R4 is 5 and the value of R2 is 0. So 5 plus 0 is 5. So that is why 3202 is 5. While R4 and R5 remain, the value is remain. Okay, next, look at the code. The code at 3202. At 3202, the add operation will be executed where the value of R5 will increase 1. So that is why in the table at 3203, 551. See, 551. Because at the in the code at 3202, the value of R5 will be increased 1. Okay, next at 3203. At 3203, you can see there the condition there is Z 0. So if the previous value is 0, the branch will be taken. But now The previous value is not 0, it is 1. The previous value means the value before the current instruction, which is the value of 3202. At 3202, we calculate the value of R5. So the previous value refers to R5. So the R5 is 1. We just add increase 1. But the condition said if 0. So now the iteration will not going to be executed because of the value of R5 is positive, not 0. So that is why after 33203, the code will directly go to 3204. So the last value of R2 is 5, the last value of R4 is 5, and the last value of R5 is 1. And the problem there, already jot down everything there. You can see there, he said that branch at 3203 is based on Z bit only. So when R5 become 1, it will not be executed and will continue to 3204. See? We already give the justification. So from the presentation just now, only 1, 2, 3, 4 of you give the correct answer, which is Primala, Nur Atikah, and Kai Zing. Jun Zuan Lee, you need to Jun Zian Lee, he stopped at 3203. So you need to add one more line, 3204. And then for Ali, you need to stop at Ali do twice, 2 times, so iteration. It should be one only. Like Nek Hasni, Nek Hasni stop sampai 3201 je. Dia tak habis. Kemudian Maizatul pun ada salah kira dekat situ, ada 10 pula. Anis so Eliza. Tapi kalau macam jawapan, if your answer like Eliza, Maizatul, Nek Hasni, you guys can get marks like 25% out of 100. Katakan markah, let's say the total mark for this question is 100. Like Maizatul, like Nek Hasni, and then Nur Eliza. Yang ni, okay, for this type of answer, you can get mark around 25 to 50. But like Anis Natasha, Muhammad Firdaus, memang total loss lah, kosong terus. 0. So like Nur Atikah, for Ali, like Ali, you can get marks around 50 to 60 if you give this kind of answer lah. Like Jun Zian Lee, he can get marks around 90% and above. So that is how I give mark based on your answer. So what can I see here? Let's say I just I put this as my analogy for the final exam. So it's proven that the result is in the bell curve. Bell curve, di mana where some of you get a good grade, some of you will get the worst grade, and majority of you will be in the middle. Okay, so this exercise, the result, prove the theory. So now you can see where is your location. You can see the bell curve and where is your location in the bell curve. So for the A students, I mean for the correct answer, I'm not worried. For the middle answer, for the middle the majority answer, I think you guys have still have a hope to improve your understanding, but you need to do exercise, or maybe you need to do a more revision, because I can see that actually you understand the concept, but when you practice it, you get confused. Why is confused? Because maybe you have no time, because I only have to give you 10 minutes, or maybe you for my consideration, I just can tell you that maybe you are not enough time to answer the question. Okay, so I have I can still have a hope that you can do better, but for the students that totally wrong, so you have a problem with the understanding. So if you have problem with understanding, the first thing that you have to do is to ask me to tell me what's your problem, so I can justify, I can clarify what is your problem. I mean, I can help you. I can help you to solve your problem. And then if you worried or you scared talking to me, that you need to do on your own, or maybe you can just ask your friend. There's a lot of friend in the group. Just PM them. PM them. They will let you know. They will teach you. Let's say if you PM somebody, I mean direct message somebody and ask question, and let's say they are not helping you or do not give any cooperation, then you can tell me. You can ask me. You can let me know who is that guy, and I will do something lah. Because we need to learn together. To those who are not master the understand the really understand the content. So your friend need to help you guys lah. Just don't let you alone. So don't worry. So you just PM or DM your friend and let them just ask them to help you to solve your problem or give you better understanding towards the content. So that is my conclusion lah about the exercise. But I'm quite impressed because some of you look like know nothing, or I mean, not know nothing, but seems that you are not understand. But I'm impressed because some of you can give a very correct answer and very clear answer, like Kai Zing and Jun Zian Lee. You really can understand the content of the topic today. Very, very good. So that's it for chapter 6. So as I told you, this part is quite important for the final assessment. So make sure you do the exercise, especially the example for example 2 and example 3. For example 4, you can skip because it's quite hard to do and it's not on par because you're just a minor, not a major for this paper. Okay, so any question for chapter 6? Ada soalan?
Sir, can I ask for this question? If I want to fix the error, how do I fix?
Okay, good question. Let's say this kind of question is appear in the exam, final exam. So to repair the code, you just copy the problematic code, which is 3203. Okay, just copy then and make some notice there, say that this is the previous code, or the code with bug, or the code with error, and then you right there change to the new code. Only one line code. Do you get what I'm trying to tell you?
Yes, sir.
Okay, so only one code. Do not write from the beginning. Only take one code or one line of code, or sorry, one instruction, and just repair the instruction. That's it. Okay,
Yeah, I understand.
Okay. Any other questions? I'm not going to stop the class at this time. I will continue with chapter 7 because we are running out of time. Do you have a class after this? Anyone of you?
No, sir.
No, sir.
No, sir.
No, sir.
Okay, I will continue with chapter 7. Yes, siapa tu? Nur Atika. Nur Atika can leave the class, but make sure you get update from your friend. Maybe you can ask help from your friend to record the class, maybe. Okay. Oh, Nur Aisyah. Oh, saya lupa nak tanya Nur Aisyah tadi. Saya tak tahu apa yang dia faham. Tak apa, minggu depan saya tanya awak. Okay, Nur Aisyah? Remind me. Okay. Okay, you both of you can dismiss the class.
Thank you, sir.
Welcome. Welcome. So we'll proceed with chapter 7. I don't think I don't want I don't think that I will go for chapter 7. I just want to skip to chapter 8 because chapter 8 is very easy. The chapter 8 is also important for the final exam. And actually chapter 8, the content of chapter 8 is refers to the input and output part of von Neumann model. Okay, input and output part of von Neumann model, and it's very very easy. I will show you the important part of this chapter. Okay, chapter 8 actually is about input and output. Okay. Um, okay. There are 4 registers that you need to know. Okay. 2 register for keyboard. Keyboard is an input, and 2 more register for output. Okay, output. So for this example, the output that the device that selected as an example is a display, a monitor. Monitor. So for the input, we take the keyboard as an example. So both of them has 2 register. Okay, SR, SR and DR. SR means status register. Okay, KB means keyboard lah. KB keyboard, S status are register, while D is data. So keyboard data register and keyboard status register. While for monitor, it has display status register and display data register. So this is what will happen. What will happen if you click something or click on the character, the button on the keyboard. So what is happening here? Okay. When a character is typed, in ASCII code is placed. Okay, the ASCII code, the table of ASCII code will be given to you. You can refer to the ISA table that I give you before. Okay, the ISA table file that I give you before. If you scroll down, you can see the ASCII table. Okay, do you have ASCII table with you now?
Ada, sir.
Ada Primala ada?
Yes, sir.
No, sir. Where to get it?
That's why I ask you if please open up the ISA table that I gave you before.
Oh, okay. I see table. Okay, I got it.
Scroll down apa nama Ding Ali, just scroll down Ding Ali.
Yes, I already download.
Okay, download. No need to download. I already gave you the ISA table. So just scroll down. At the bottom part, there is a ASCII code I only gave you. If you download from the internet, there's a lot of format. You will get confused. So just use the ASCII table that I gave you. Do you have? This one. Here we have ISA table. This ISA table, I already WhatsApp this to you. If you scroll down, here we have ASCII table. See? Can you see this, Ding Ali?
Sir, I have already opened.
Okay. So you can see. Let's see the ASCII table first. Okay. So it starts with 00. Okay, 00 in hexadecimal. All the numbers starting from 00 to 7F is in hexadecimal. Okay, this representation represent the code, the button on the keyboard. For example, if I said capital letter A, okay, the ASCII code for capital A is 41. 41 is in hexadecimal. So if you convert this hexadecimal into binary, what will you get? Let me know. 41 convert 41 hexa, convert to binary. What will you get?
One zero 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 one.
Pardon? Ulang balik.
1000001. Zero ada 5 kali.
No, it should be start with 0. Okay, what is the formula for hexa to binary? What's the formula? Apa formula dia?
To
One digit hexa equal to one digit hexa equal to how many binary?
first digit is 2 power. I think 2 power 0 multiplied by 16 and then plus.
Not as hard as that. It's very simple. Can you guys, can you remember how to convert hexa into binary? Did Ali how to convert hexa into binary? Anyone knows? How many bit for one digit hexadecimal?
Sir, 4 bit.
4 bit. Yang lain kenapa diam? Okay, Primela, what's the representation of binary for 41 hexa? Already give the hint to us.
So can you repeat the question?
The question we are going just now.
What is the what? What is the
Class, what I asked you to do?
Change 41 to binary. 41 hexa to binary.
That is it, Primela.
Is it the answer is 01000001?
Right. So 01000001. Remember that, 01000001. Okay. So that binary, okay, we go back to the slide, We go back to the
It's
slide.
5 o'clock.
Okay. When a character is typed, let's say we type a capital A. What is happening is its ASCII code is placed in bit 0 to 7 of KBDR, where bits 8 to 15 are always 0. While for KBSR15, it will be set to 1. So means that before the character is typed, the KBSR15 is 0. But once it types, KBSR15 is set to 1. Okay. Then keyboard is disabled. It means something is in use. Means that you are pressing the button. So if you press another button at the same time, so it will be ignored. Why? Because the ready bit is already 1. Once means the register is in use. So if you type anything after, so everything will be ignored. Okay, once the KBADR is read, the content of the KBADR is read, the KBSR15 is set to 0 and keyboard is and above. So what does it mean here? It means, okay, let's say I show you how it works. So I will insert a table here. So again, we have 16, 2, 4, 6, 8, 10. We have 16 bit, 1, 2, 3, 4, 5, 6, 6 more to go. 2, 4, 3. So this is how it looks for KB, both KBEDR and KBSR. So 16 bit. So this one is for KB. Let's say this one is for KBSR, status register. Okay, I'll put some things. I'll put some note here. Okay, that's fine. The KBSR is green. I use another color lah. I change the color. I use blue. Okay. So the blue one is for KBDR. KBDR. Okay. So both have 16 bit. So I repeat, the green one is KBSR. The status. Status means either it is in use or it is free. Okay. While KBDR contains the content of the register. I mean the ASCII code. Okay. So if you look at the statement there, by default, the value of KBSR 15, of course, 0. 0 means it's not in use. It's not in use, so 0. So KBSR 15 is 0. The green one is KBSR, while the rest of the bit will be also 0. 2, 4, 6, 8, 9, 12, 14, 16. Okay. This is KBSR. KBDR also, by default, it contains nothing. It contains nothing. I will use black here. Okay. This part is very easy, very easy because we only have 4 register. So we want to see what is the content of the register while we press something on keyboard and when we see something on monitor. So input and output. So this is by default. So both register contains 0. 0 and nothing. And then let's say when we type A, when we press A, capital A, so what is the representation of, okay, before that, when we press A, so it shows that the keyboard is in use. Okay, when the keyboard is in use, so the value of KBSR 15 here is 1. 1 means it's in use. Okay, at the same time, okay, the binary code for capital A, let's say we type capital A, okay, the capital A just now is 41. So what is the value in binary just now?
0,
0, 1,
0, 1.
0, 1, 0, 0,
Uh-huh.
and then 0, 0, 0, 1.
Okay, so 8 bit, 8 bit here. Okay, starting from here, 1, 2, 3, 4. Listen, okay, 1, 2, 3, 4. Here. So 0, 1, 0, 0, 0, 0, 0, 1. This one is 41. 41 is A. So this is what is happen. What is happening while we press capital A on keyboard. So the status register, the 15 bit will be 1. It shows the keyboard is in use, while the representation of A in binary will be inserted into KBDR. Okay, this is the first phase. Means that you press something on keyboard. Okay. Okay, when KBDR is read, when KBDR is read, before KBSR15 is set to 0, something, one register must hold the value. I mean the A value, to make it there. If the value is not whole, if nothing hold the value, the A will be disappear. So it won't display on the monitor. So who gonna accept the value? So that value will be accepted by the DDR, the data display data register here. This one. So I will copy both of the register just now because it is connected with the DSR and DDR. So I copy this and I put it here. Okay, this one is KBSR, KBSR. Okay, this one is KBSR. And then the KBDR, keyboard data register, it has this one. And this one. Okay, we put it here. Here. Okay. So now we have both registers are here. And then we draw two more registers, which is for DSR and DDR. So this one we bring here. Okay, and then we draw the DSR, the display status, the status register for the display. I use another color. I will use yellow lah, yellow. Okay. Okay, this is for the DSR, which is status, to show either the monitor is in use or not, or free. Okay. So next we have DDR. I mean the content that we want to display using the monitor. So here I use maybe brown. Oh, similar color. Maybe blue. Okay, blue. Okay. Okay. Let's see the initial part or content of the DDR and DSR. Okay. when monitor is ready to display another character. Ready means it's ready lah, ready to display. It is not displayed yet, it just ready. So means that by default, the status register is 1. While the content of course 0 lah. Okay, this is by default. So okay, before we change the status register for KBSR to 0, means that ready to accept any input. Before we do that, we copy the content of KBDR, this one. We copy this into DDR. So what is happening here is what? Okay, when we copy this into DDR, okay, what is happening is we copy this one to here, 1 and 1. Okay, we copy this, and then we change this KBSR to 0. So means the content from KBDR is already copied into DDR. And the last step is to display the content of DDR, which is we just change this one to 0. So at this stage, the capital A is already displayed on the monitor. So means that keyboard is free because the status is 0. Okay, keyboard is free, the status is 0, and the content is already copied in the DDR. Okay, and the content in DDR is already displayed on the monitor. So this is the final part when the content of KBDR is displayed on the monitor. If we want to restart everything, so the status register for monitor should be 1. 1 means it started back, it restart. We are ready to display another character. Okay. So from this procedure, why don't we try to do a sequence of alphabet? For example, we take B and C. What is happening in the register while we type B and C? Okay. Okay. We restart everything. So let's say the content of KBDR is 0 and the content of DDR is 0. So both register contain content because KBDR means data, D means data. Okay. Okay, this is the by default. Wait, I just want to check the. Okay, KB is set to 0. Keyboard. Okay, keyboard is enabled when KBSR15 is set to 0. Okay. So at this stage, okay, keyboard is ready. Means keyboard is enabled, so it's ready to accept any input. Okay. Now let's say we type B. We type B, capital B. If we look at the ISA table, B is 42 and C is 43. Capital B and capital C. We type B first and then following by C. 42 and 43. So what is happening is, okay, when we type capital B, okay, the status register for the status register for keyboard will be on. Means that the keyboard is in use. And then the 42, which represent B, will be kept in KBDR. So 42 just now. 42. This one is 42. So means that B is already pressed on the keyboard. Okay. Now we want to display B on the monitor. Before we get C, we need to display B at first. So now we want to display this B. So what is happening is, okay, Okay, copy the content. First of all, copy the content of B42 into DDR. Just copy like that. And then the status register for keyboard will be 0. It means it's ready to accept or receive another alphabet. But the display does not display B yet. Okay, now we want to display B. So if we want to display B, we need to change this one, the DSR, to 0. After we do this, so the content of DDR or B will be displayed on the monitor. So in the same time, we can input C. C is 43. So we change the status register for keyboard to be 1. And then the content for DDR to be 43. Okay, at this stage, C is already typed on the keyboard, but on the monitor, it is not displayed yet. The monitor still display B, not C. Okay, I repeat, at this stage, the B, capital B, is already on keyboard. The button is pressed. But in the monitor, there is no B yet. It's only C. Why? Because the content of DDR now here is C, see? Sorry, B. One is B. Okay, now, okay, how to replace B with C on the keyboard. So now we already have C in the KBDR. So what's next? We just copy this C into this one. Here, DDR. So here now we have C in DDR. Oh, sorry, we're not setting this yet. Wait. Okay, after display B, okay, the status register will be 1. It shows that it's ready to display another character. After this is changing to 1, then we copy C into DDR. So after we copy C into DDR, the status register for keyboard can be 0 lah, because the value is already passed to the display. And then the last step is to display the content of DDR. So how to display the content of DDR? We'll just change the value of this one, status register, as 0. After we change this, so the C will be displayed on the monitor. So that is the process when we type 2 characters or 2 alphabet on the monitor. Okay, any questions? Itu je chapter 8. That's it. Chapter 6. Chapter 8.
No questions.
No questions. No question because you understand or not understand?
I understand.
Understand, sir.
Understand, sir. Very clear.
Seriously?
Yes, for input output.
Oh. Can someone repeat what I'm telling you just now? Any one of you? Maybe siapa ni? Yeah, I want. Of course tak akan ke depan kan?
So repeat from the start.
Repeat from the start. Sorry, pada ni?
I mean, repeat from the beginning.
Repeat from the beginning. But,
one letter or
2 letter because we want to see the sequence.
okay. So at the beginning, the KBSR.
Okay, wait. Okay, you just tell me what I should do. I just use the table that I provide here. Okay, I will empty all the bit here. I will empty first. We make it empty. Okay, this is by default. This is the condition of the register. The green one is KBSR. The grey one is KBDR. The yellow one is DSR. While the blue one is DDR. E means data, which means it contains data. While S means status. Status means either it is in use or not in use. That's it. So by default, all bits are 0 except what? Except this one, ESR15. ESR15, when it is ready to display another character, okay, 1, the value is 1. Okay, so this is by default. This is the starting, the beginning of the process. Okay, let's say I ask you to this type and display number starting from 6 and then 7. Okay, what would you do? 6 and 7, Okay. You can start now.
Okay, so at the beginning, for the KBSR, the bit 15 should be set to 1 once you have typed on the keyboard. So after you have typed on the keyboard, the data should be inserted into KBDR. So the data that should be inserted is 00110110.
Alamak, pardon.
Oh, sorry. 0011 and then 0110.
0110. So this is?
This is 6.
36.
Yes, 36. In the S.
Okay, 36 in hexadecimal. Okay.
Next, for the DSR, the bit 15 should be set to 0.
Not yet. Not yet. Because if you set to 0, it will display the content, But,
so should be copied first.
Copied first.
So the data from KBDR should be copied to DDR.
Okay, yeah. Okay. Before copy, you see here, I want to show you one note here. This one, Okay, this is KBDR. When KBDR is read, so means that when we read the content of KBDR, read means we copy the content from KBDR to DDR. So when we do this, KBSR15 need to set to 0 first. Okay. It is a him. So it's set to 0 and then the content will be copied. Okay. Okay, let's start again.
Okay, so should it be set to 0 first, then copy, or?
Yes.
Okay, so KBSR should be set to 0. So
Okay.
15.
Okay.
And then data from KBDR copied to DDR.
Okay.
And then the data is displayed. So now the KBSR should be set to 1 again.
Okay.
The KBSR.
Okay, KBSR set to once mean we need to we can something is typed on the keyboard. But now we have not displayed 6 yet because DSR is 1 here.
Oh, DSR.
You see here, the notes here, DSR 15 is set to 0, the character is displayed. See? So we need to set this to
0.
So now 6 is already displayed on monitor. Okay. And continue with 7.
Okay, so after the data is displayed, KBSR bit 15 should be set back to 1 after you have typed the new number. So after you have typed the new number, the data 7 should be inserted into KBDR. So the value should be 0110. 0011.
0011. Okay.
And then 0111.
Okay.
And then after that, the KBSR should be set to 0. Then copy the data to DDR.
Before that, this one, you need to change this to 1 first. Because
DDR,
1 is ready.
So DDR should be set to 1 first.
After display this one, after display the content of DDR, to DSR will be 1. Okay? Alright.
And now the KBSR should be set to 0.
Okay.
And the data should be copied to DDR.
Okay, good.
So once data has been copied, the DSR should be set to 0 again. And then should be outputted on the monitor.
Yes, good. That's it. So if you want to restart again, you just change the DSR 1 because this is the default value for the DSR. Okay. So that's it. Any questions? Nek Hasni, boleh tak?
Boleh sir. So KBDR tu untuk binary yang ABC tu sir.
Kena cari dia punya binary untuk ASCII code.
So benda ni guna untuk binary yang huruf je lah sir.
Semua lah, nombor-nombor, tanda-tanda seruan, koma, semua yang ada.
Okay sir.
Exclamation marks, everything, any button that on the keyboard, we can refer to ASCII code.
Okay sir. Sir, I don't find my ISA table.
Saya ada bagi dalam group, cuba cari bagi dalam group. WhatsApp.
Saya tak jumpa, tak apa, nanti saya balik.
Nanti kalau okay, saya dulu cari dulu. So that is the procedure of pressing something on keyboard and displaying something on the monitor. Maybe you a bit confused with DSR because like keyboard, if the keyboard is in use, the status will be 1. So it's normal lah. Anything that we use, the status will change to 1. But for monitor, if it is ready, it's 1. But when it is in use, it will be 0. These things may be quite confusing, but it's easy to understand actually. But don't forget to copy like told us just now, before you change, let's say we type something on keyboard like this, okay, before we change this KBSR to 0, make sure we copy the content of DDR KBDR first into DDR. This is very, very important. If not, it will be lost. You type the word, you type something on keyboard, but it will never display. That is happening if you change the status, the KBSR, before you copy the content. So please be careful. And also this one, DSR. After you display the content of the DDR, make sure you change this back to 1. So by it's become it's written to the beginning of the procedure. Okay, any questions?
No, sir.
Junjiani, okay?
I think I'm okay.
Okay, good. Zhang Kaizeng? Maybe he has an internet problem over there, but never mind. So as for today, okay, good. So that's it for chapter 8. So for next week, we will learn about chapter 7. And before we go through chapter 7, please install the software that I give you in my Guru. Okay, the name of the software is, I guess, LC3, if I'm not mistaken. I give two installer. One is for the to draw the circuit. That one is electronic workbench, EWB. The file name is EWB. That one is not used anymore because we already used it during chapter 3. But for next chapter, chapter 7, we will going to use the LC3 software. So you can find it out. That wait, let me check in my Guru first. Is there or not? Wait. This software will help you to convert the the LC3 language into machine language. So it's easier for you to do a revision, because it will help you to convert the language automatically. Eh? Let me check first in my Guru either the installer is there or not. Uh, chapter 7. DPT video. Oh, link accessible language. Where's the installer? Oh, there's no installer. Input output. Let me see. Input output PPT. Chapter digital version WP. Lah. There is no installer lah. Where to put installer? Wait. Human edit SC language video chapter. Okay, wait. I'm not sure either. I'm not uploaded it because of the installer. Video LC3 EXE. Cool. The file type is not allowed. So this is why I can't upload it in my Guru. Macam mana nak buat ya? How to transfer the EXE file? Can we use WhatsApp or? Let me try to open up my WhatsApp web. I hope that it works. Okay, this one.